in our object-oriented programming in C++ series here at Database Tutorials. So in this chapter, we're going to be learning how to code the basic program. And so let's take a look at our book here. And so let's take a look at our basic program construction here. This is a very simple C++ program. The program is called first, so its source file is first.cpp. It simply prints a sentence on the screen. And let's go ahead and let's follow along with that here. So we're going to do an include. We're going to do an include, and we're going to do IOStream. And then that's going to be using namespace std. This is the standard C++ program setup. And then here we have to make sure we include a semicolon for end line. And then here in our int main, this is our main function. This is what drives C++. And then we're just going to print some text out on the screen using the count, and we're going to say every age has a language of its own. And then we're going to do a \n. That's going to be new line. You're soon going to learn about that. And that's going to be new line. And then I'm going to do a semicolon here, and then my return is going to be 0, so we're not going to have any return statement in our main here. And then let's talk about it. So this program demonstrates a great deal about the construction of C++. Functions are one of the fundamental building blocks of C++. The first program consists almost entirely of a single function called main, which we see here. The only parts of this program that are not part of the function are the first two lines, the ones that start with the include and the using namespace. We'll see what these lines do in a moment. We noted in Chapter 1 the big picture that a function can be part of a class, in which case it's called a member function. However, functions can also exist independently of classes. We are not ready to talk about classes, so we will show functions that are separate standalone entities as main is here. Function name. The parentheses following the word main are the distinguishing feature of a function. Without the parentheses, the compiler would think that main refers to a variable or to some other program element. When we discuss functions in the text, we'll follow the same convention that C++ uses. We'll put parentheses following the function name. Later on, we'll see that parentheses aren't always empty. They're used to hold function arguments, values passed from the calling program to the function. The word int preceding the function name indicates that this particular function has a return value of type int. Don't worry about this now. We'll learn about data types later in this chapter and return values in Chapter 5. Functions. So what we just talked about. We just talked about how functions look, and when we build functions, we put the name followed by parentheses. So this is, and then in the beginning we have the type. So our type is integer, which is the object class, and the name of the function is main, and followed by parentheses. And we can look at this again where it says, without the parentheses, the compiler would think that main refers to a variable or to some other program element. So that's why it's important to have those parentheses there. Braces and the function body. The body of a function is surrounded by braces, sometimes called curly brackets, which we see here in our integer main function. These braces play the same role as the begin and end words in some other languages. So if you're familiar with SQL or MySQL, where we use a begin and an end to end a procedure or a function, then that's probably what you'll be familiar with. But here in C++, it's going to be curly brackets or braces. They surround or delimit a block of program statements. Every function must use this pair of braces around the function body. In this example, there are only two statements in the function body, the line starting with COUT and the line starting with return. However, a function body can consist of many statements. So our function body here has COUT, which prints text out on the screen. That's one statement, and then the next statement is the return statement we have here, and each is ended with a semicolon to end each statement. And functions can consist of even more. If we wanted to add another statement, we could add another one in here. Braces in function body. The body of a function is surrounded by braces, sometimes called curly braces. These, oh, we just read this. Sorry, guys. Always start with the main function. When you run a C++ program, the first statement executed will be at the beginning of a function called main. At least that's true of the console mode programs in this book. The program may consist of many functions, classes, and other program elements, but on startup, control always goes to main. If there's no function called main in your program, an error will be reported when you run the program. So a C++ rule, each program has to have a main function, otherwise it will fail to run properly. In most C++ programs, as we'll see later, main calls member functions in various objects to carry out the program's real work. The main function may also contain calls to other standalone functions. So main is going to be used to call member functions in other objects. So when we start getting into object-oriented programming, our main function here is going to be able to call functions that can trigger those objects to do certain things, and it'll all be in here in main. Let's talk about program statements. The program statement is the fundamental unit of C++ programming. There are two statements in the first program. The line COUTT, every age has a language of its own, and the return statement, return 0. The first statement tells the computer to display the quoted phrase. Most statements tell the computer to do something. In this respect, statements in C++ are similar to statements in other languages. In fact, as we've noted, the majority of statements in C++ are identical to statements in C. So C++ and C have some similarities. There are some differences, but if you're very familiar with C, then you'll know, then it should be very easy for you to catch on to C++. A semicolon signals the end of the statement, as I noted before, each statement ending with a semicolon. This is a crucial part of the syntax, but easy to forget. A lot of people will write statements and they'll forget to include their semicolon at the end, and it'll result in an error upon compilation. In some languages like BASIC, the end of the statement is signaled by the end of the line, but that is not true here in C++. If you leave out the semicolon, the compiler will although not always signal an error. The last statement in the function body is return 0. This tells main to return the value 0 to whoever called it. In this case, the operating system or compiler. In older versions of C++, you could give main the return type of void and dispense with this return statement, but this is not considered correct in standard C++, and we'll learn more about this in Chapter 5. So whichever object or procedure called our main function, it will return a value of 0 based on what we have here. Now, if we were to change that and put something else, then what called our main function will return whatever it is that we put inside that method there. So white space. We mentioned that the end of a line isn't important to a C++ compiler. Actually, the compiler ignores whitespace almost completely. Whitespace is defined as spaces, carriage returns, line feeds, tabs, vertical tabs, and form feeds. These characters are invisible to the computer. You can put several statements on one line, separated by a number of spaces or tabs, or you can run a statement over 2 or more lines. It's all the same to the compiler. Thus, the first program could be written this way. So we do our include statement of IOStream using namespace std. If we add a white space in there, it's not going to make a difference. It's still going to see using namespace std. We could do int main and then have our curly brackets way out here. And then we could do a COUT out here and then add a white space in here and then break it down and have our text here and then have even our semicolon to end line could be on its own white space. and the return statement could be up here, and then its return value and line semicolon can be down here, and it's not going to make a difference in compilation. White space is completely ignored here in C++. But we don't recommend this syntax. It's not standard and hard to read, but it does compile correctly. So it's recommended to do your statements in a more simplified and easy to read way for the user. You'll have other people looking at your code, and you want to make it easy for them to understand. And so if you do your white spaces simple, then it'll be easy for them to follow along with you and understand the logic that you have written in your C++ program. There are several exceptions to that rule, that white space is invisible to the compiler. The first line of program starting with the include is a preprocessor directive, which must be written on one line. Also, string constants, such as every age has a language of its own, cannot be broken into separate lines. If you need a long string constant, you can insert a backslash at the line break or divide the string into two separate strings, each surrounded by quotes. Output using COUT. As you've seen the statement, COUT, every age has a language of its own, causes the phrase and quotation marks to be displayed on the screen. How does this work? A complete description of this statement requires an understanding of objects, operator overloading, and other topics we don't discuss here until later in the book, but this is a brief overview. The identifier COUT, pronounced cout, is actually an object. It is predefined in C++ to correspond to the standard output stream. A stream is an abstraction that refers to a flow of data. The standard output stream normally flows to the screen display, although it can be redirected to other output devices. We'll discuss streams in chapter 12 when we talk about streams and files. The operator, I guess you could call that with 2 pointers. It's called the insertion or put to operator. It directs the contents of the variable on its right to the objects on its left. So whatever is on the right is what these 2 pointers are going to be controlling. So if we were to do another 2 pointers in here and add more text, then these 2 pointers would be referencing this line of this string, and would be unable to access this string here. And this string would only be able to be accessed by these 2 pointers. So, which should be called the insertion or put to operator. So we'll call this the insertion or put to operator. That's what we're going to call that. So if you know C, you'll recognize these two as the left to shift bitwise operator and wonder how it can be also used to direct output. And C++ operators can be overloaded. That is, they can perform different activities depending on the context. We'll learn about overloading in chapter 8 when we talk about operator overloading. Although the concepts behind the use of the cout and the insertion operator may be obscure at this point, using them is easy. They'll appear in almost every example program. And if we see here in our figure 2 shows the result of them using the cout and the insertion operator. Here, the cout sends the data straight to the computer to be displayed on the screen, and the insertion operator is pointing the variable here that's being passed in to the cout operator to be displayed on the screen. So that's how you output with cout. Now let's talk about string constants. The phrase in quotation marks, every age has a language of its own, is an example of a string constant. As you probably know, a constant, unlike a variable, cannot be given a new value as a program runs. Its value is set when the program is written, and it retains this value throughout the program's existence. So our phrase here, every age has a language of its own, is an example of a string constant. And it cannot be given a new value as the program runs. It has to always remain this value, which is every age has a language of its own. Now, as we'll see later, the situation regarding strings is rather compiled in C++. Two ways of handling strings are commonly used. A string can be represented by an array of characters, or it can be represented as an object of a class. We'll learn more about both kinds of strings in Chapter 7 when we talk about arrays and strings. The character \n character at the end of the string constant is an example of an escape sequence. It causes the next text output to be displayed on a new line. We use it here so that the phrases such as press any key to continue inserted by some compilers for display after the program terminates will appear on a new line. We'll discuss escape sequences later in this chapter. So having this in here will create a new line here. So anything that we were to put after this would be on a new line. So if I were to add words after new line, then that's what's going to display after the new line. So that's how that's going to work for us. Directives. The two lines that begin the first program are called directives. The first is the preprocessor directive, and the second is the using directive. They occupy a sort of gray area. They're not part of the basic C++ language, but they're necessary anyway. So this is a preprocessor directive that you see here. Our include statements are preprocessor directives, and our using directive is our using namespace std. Preprocessor directives, the first line of the first program, include IOStream. Might look like a program statement, but it's not. It isn't part of a function body and doesn't end with a semicolon. As program statements must, instead, it starts with a number sign. It's called a preprocessor directive. Recall that program statements are instructions to the computer to do something, such as adding two numbers or printing a sequence. A preprocessor directive, on the other hand, is an instruction to the compiler. A part of the compiler called preprocessor deals with these directives before it begins the real compilation process. So a preprocessor directive is always going to run first before any other program statement, and using the number sign is how you specify a preprocessor directive. The hashtag include is only one of many preprocessor directives, all of which can be identified by the initial hashtag sign. The use of preprocessor directives is not as common in C++ as it is in C, but we'll look at a few additional examples as we go along. The type file usually included by hashtag include is called a header file. So if you were to create an additional file in here, in our header file section here at the top right hand corner, and I'll just drag that over here, you see we have stdafx.h, and if we open it up here, it also has another preprocessor directive include of the target over.h header file and the stdio and tchar.h, and these are other header files. So when you create a new header file and you want that header file to be associated with your C++ program, you use the include preprocessor directive, and in quotation marks you include your header file here at the top. And so that's what we've done here. And then we move on and we talk about header files. In the first example, the preprocessor directive hashtag include tells the compiler to add the source file IOStream to the first CPP source file before compiling. Why do this? Well, IOStream is an example of a header file, sometimes called an include file. It's concerned with basic input-output operations and contains declarations that are needed by the cout identifier and the insertion operator. Without these declarations, the compiler won't recognize cout and will think the insertion operator is being used incorrectly. There are many such include files. The newer standard C++ header files don't have a file extension, but some older header files left over from the days of the C language have the extension .h. If you want to see what's in IOStream, you can find the include directory for your compiler and display it as a source file in the edit window. Kind of similar to how we have other header files here in our header window. Or you can look at it with the WordPad or Notepad utilities. The contents won't make much sense at this point, but you would at least prove to yourself that IOStream is a source file written in normal ASCII characters. We're not going to look at it, so we're just going to trust his judgment, and we're going to say that it is a header file, and we believe it, seeing as we have other header files here in our Solution Explorer. So we'll return to the topic of header files at the end of this chapter when we introduce library functions. The using directive. A C++ program can be divided into different namespaces. A namespace is a part of a program in which certain names are recognized. Outside of the namespace, they're unknown. The directive using namespace std says that all the program statements that follow are within the std namespace. Various program components such as cout are declared within the namespace. If we didn't use the using directive, we would need to add the std namespace to many program elements. For example, in the first program, we'd need to say std cout if we didn't use our using namespace. So if we were to remove our using namespace here, then we would have to include std : cout. So I'm just gonna we're gonna stop. We're gonna end video here. We're gonna break this down into a few videos. We don't want to overload the mind with too much information, but we just learned a lot. And if you're with me right now, you should be feeling pretty good about yourself because this book is explaining this stuff very well so far. So if you're interested in the next video, head on over to our YouTube channel, our database-tutorials.com, and hit that subscribe button. And yeah, until next time.